Hello everyone, let's go to next topic about syllabus. That is nothing but what? Electric potential and potential energy. If you remember, the potential energy changes with the height. If you remember, we have learned the potential energy PE equal to mgh. Here h is height. As height increases, potential energy increases. But in this electrostatics, what exactly is the potential energy? So the potential energy itself is nothing but in electrostatics. The definition little get deeper from this. What is the definition in electrostatics then? In electrostatics, the potential energy is nothing but a amount of work done required to move the charge in the presence of another charge. The amount of work done required itself is said to be the potential energy. I know that you didn't clarify it, so let's start with the example of this. Suppose we have one charge here plus q, so this charge is plus q, and suppose another charge we are moving from infinity. This is another charge, again a positive, it is plus q. We want to move the charge from this place to this place. Now initially, if this charge plus q is kept here, and suppose this is charge plus q1 kept at infinity, this is kept at infinity, this is kept at a point A. Now we have to move the charge from infinity to the point near to the point A, or suppose at certain point this as B. We want to move the charge q1 from infinity to the B. Now to move the charge from infinity q1 to B, some work done is required, and that work done itself is nothing but a increase in potential energy in electrostatics. Now remember, this charge is here, this can't apply this can't apply or exert some force on this. At the same time, this charge is at infinity, so it can't apply or exert some force on this charge. So when we move the charge q1 from infinity to the point B in the field of charge A, then there is what? Force of repulsion, or it may be attraction. In our case, it is repulsion because both are positive. That will constitute a work done to move it from q1. So I have to hold it and we have to move it to the point B. So charge plus q1 comes here. So I have hold it and move it to here. Some force is required apart from the force. Some work done is apart from force. Some displacement is required. Suppose dx, and force into displacement constitute a work done, and that work done to move the charge q1 from infinity to the given point B is nothing but a increase in potential energy in electrostatics. I hope that little bit you get the idea about this. Read the same topic from a book, you get a better understanding of the same topic. So amount of work done required to move the charge from infinity to the given point, that work done itself stored in the form of potential energy. So we can write here the work done itself can be stored in the form of potential energy. Suppose the work done was represented by the force is suppose F, the displacement is we have taken dx, here they have taken dr, then this is said to be in turn the change in potential energy du. So this change in potential energy, force into displacement, means it is work done to move a charge from infinity to the given point itself. Now let's go to the expression for potential. Expression for potential energy. Equation for potential energy. Just draw the equation for potential energy. For that, just we have to assume one diagram as they have plotted in the book. We will draw a diagram. Let us consider the point O. So this is the point O, where we have kept charge plus Q, plus capital Q is a charge kept at point O. At a point B, the distance is, suppose it is this distance between at point B and O is nothing but a R2 they have taken, and another point they have taken whose distance from this O they have taken as R1, and this point is somewhere here, and that point is nothing but what? Point A. This is a point A where they have, this is a point B, this is a point A where the another positive charge is kept, and that positive charge is plus q0. That is a positive charge is plus q0, and further here there is a force, electrostatic force F going to the right hand side direction represented by F suffix E. Okay, now here suppose, so this will be the situation, and somewhere here we are moving this by a distance dr. Okay, so just they have taken this as a dr. So this is nothing but what? the diagram. Here what we have to consider in this diagram, let us consider the 2 points. So just I will move the mobile little bit front so that you can see clearly this diagram. So let us start with this. So what we have to see, electric field, expression for potential energy. So let us consider point O where we have kept charge plus Q. Let us consider another point B at a distance of R2 from O. Consider another point A at a distance of R1 from O, where at a point A we have kept charge plus Q. We want to move the charge plus Q, place at A, move it to the B. So the work done required to move the charge plus Q0 from A to B, it will create itself nothing but what? Potential. Work done required to move the charge plus Q0 from A to B, that work done can be considered as a increasing potential energy of this system. Now for that, so let us consider first initially we have to write the equation that we have seen. As we know, the potential energy equal to work done, and that is nothing but equal to F into displacement dr. Let us consider that here what we have done, we try to move the charge plus Q0 to B. Before that, certain point is here, we want to move the charge plus Q0 by a distance dr. So this Q0 charge moved by a distance dr. So it is equal to what? Force into displacement is dr, and force is here F suffix E. So F suffix E into dr, that is force into displacement, is a work done, and that work done itself is nothing but a potential energy. So I have written here du potential energy equal to Fe into dr. Same equation, this is in vector form we can write. So same equation can be written in the another form as this is equal to minus Fe into dr. Why the minus Fe? Because we are moving a Q0 to left hand side, force is moving to right hand side, so they are moving in opposite direction. That's why the minus sign was introduced here. So this is the amount of work done to move the charge Q0 from A to distance dr. But we want to find out amount of work done required to move the charge Q0 from A to B. How much work done is required, that we want to find out, and that total work done can be find out by integrating to get a total energy, the potential energy delta U equal to integration of Fe into dr while moving from minus sign, it is while moving from R1 to R2. This distance from O is R1, this is R2. So we are moving from A to B means what? R1 to R2. So integration moves from R1 to R2. We have to find this equation. Once we find out this integration, we get here, what we get here? We get a potential energy. Okay, expression for potential energy. Now here Fe is here. Fe is said to be electrostatic force. So we know that electrostatic force is what? According to Coulomb's law, electrostatic force of attraction, in this case plus attraction. If it is negative, repulsion here, if any one of this is negative, there is a force of attraction. Electrostatic force of attraction or repulsion between any two charges was given by Fe equal to 1 divided by 4 pi epsilon 0 into Q, capital Q is there, into Q0 divided by R square, distance square. So this is expression for this Q0 divided by R square. So this is the value of Fe according to what? Coulomb's law. This is said to be Coulomb's law. Coulomb's law. So put this value in this equation, rewrite this. So we can write integration over R1 to R2 minus of 1 divided by 4 pi epsilon 0, then what? Q into Q0 divided by R square into dr. So we get this equation. So further, 1 divided by 4 pi epsilon 0 and Q into Q0, these are not dependent on R. So take them outside and rewrite the equation. So I will rewrite the equation little bit nearby me. So nearby side of this, I will write the same equation further. So let's write down the same equation further. So you can write here delta U equal to 1 minus 1 divided by 4 pi epsilon 0. This does not depend. Q divided by Q0, that also taken outside. Q into Q0, that also taken outside. The minus sign, integration from R1 to R2. What is remaining? 1 by R square dr. 1 by r square dr. 1 by r square, move it to numerator. What it comes? It comes to be r to the power minus 2. I will write directly here. R to the power minus 2. 1 by r square means r to the power minus 2. So here just we want to find out its integration. So if we find out its integration, comes to be q into q0 divide by 4 pi epsilon 0 in the bracket. Integration of r to the power n dr equal to r to the power n plus 1 divided by n plus 1. This is the formula for integration. In our case, r to the power 2 is what? R to the power minus 2 dr in our case. So it should be what? Minus 2 plus 1, r to the power minus 1 divided by minus 2 plus 1, it is minus 1 again. So it is minus of this. In our case, it comes to be r to the power minus 1 with negative sign, minus 1 by r we can see. So put it here, 1 by r with a negative sign. Limit varies from r1 to r2. By this formula we have drawn it. Let's go further. Those who don't have mathematics, don't worry, this is formula in mathematics to find the integration. Put here n equal to minus 2 and solve it, we get this. So just same way we have written the formula and we get this equation like this. Apart from this, now we know upper limit minus lower limit. So this minus sign cancelled out, we get plus q into q0 divided by 4 pi epsilon 0 into 1 by upper limit minus lower limit, 1 by r2 minus 1 by r1. So this is the formula for change in potential energy or increase in potential energy is given by this formula. q0 divided by 4 pi epsilon 0, 1 divided by r2 minus 1 divided by r1. That will give the equation for potential energy. And this equation for potential energy itself is nothing but this F into dr is work done. So we can write itself, it is nothing but a work done. Itself is nothing but a work done. Same thing is there. Now here, if we consider that point here, we have moved this q0. We have moved this q0 from A to B. But generally, this q0 can be moved from infinity to the point B. Okay. When we go to the infinity, r equal to infinity to r equal to r. So we put the values r1 equal to infinity, r1, the bigger distance. Is at A, we can put it in infinity. So r1 equal to infinity to r